Right, so my name is Fredrik Nygren. I am the Solutions Engineering Manager for NetApp in Sweden. That's just a fancy way of saying pre-sales manager. So today we're here with Nvidia and Konoa. But let's start with NetApp. And actually, let's start with something else. So today, data is a rocket fuel for artificial intelligence. Data is really foundational for AI. And the more data you have, the better your AI will be. So where does all this data come from? Well, there are three big meta trends in the world today. Things that have gone from being hype and buzzwords into proper trends affecting everything we do. So the first one is this one, urbanization. So all of us, we stop being farmers, we move into cities, generates huge amounts of data. We have to plan traffic, we have to plan where we build our buildings, we have to plan public transport. But that's not the biggest reason the way we get more data. The second reason is this one, globalization, where we can order goods and services from anywhere in the world. I can go on my cell phone and buy things from AliExpress, and if everything works and our Swedish postal service doesn't stop it, then I also get my goods. So this also generates a huge amounts of data, logistics and transport. But the biggest source of data today is digital transformation and digitization. Digital transformation is at the top of every CEO's agenda. It's something that the board discusses. It's the first time they probably discuss technology at all. And the reason why companies and organizations start their digital transformation is usually one or more of these three things. You want to have a direct connection with your end customer. You want to know more about your customers. You want to create new business opportunities based on that data, and you want to optimize your operations. So what does that require? If we have a lot of data and we want to do new things with data, what does that actually mean? Well, we did a study together with IDC to see how organizations look at their data. So over to the far left here, we have data resistors and data survivors, companies who see data as a cost, because first of all, you have to store it, then you have to protect it, then you need storage admins to take care of all of those boxes, and oh, you need a backup admin as well. And all of a sudden, it's a huge cost. So you want less data because it's just a cost. Over on the right side here, we have data thrivers and data synergizers, organizations that look at data as a resource, something that can be mined and that you can extract value from. So more than 50% of organizations are still data resistors and data survivors. And NetApp, we're not data thrivers either. We're data synergizers, maybe. And I wanted to talk to you about what we actually do with our data. So all of the storage systems that we have sold since 1992 send telemetry data back to NetApp. So that can be things like, did this hard drive break? How much data have I stored? How fast are the fans spinning? When did we last log into the system? All of that kind of data we send back to NetApp. And that data lake is actually 4 petabytes large now. And we've always used that data to see, well, which parts break more often than others. Which services should we create more of and which should we stop doing? But we realized that there's a way to get more value out of that data. And one thing we did is we took all of our 4 petabytes and we replicated it to a copy that sits right next to the public clouds, so Amazon and Azure in our case. And we use AI in the clouds to look at this data to send proactive alerts to our customers. So we can say, well, that hard drive is going to break in 10 days because it's starting to show a pattern that we saw in other customers, and you should replace it right now. So that's one thing we do. Something that we don't really talk about that we also do is that we look at the data in our data lake to see which customers are going to leave NetApp in the coming 3 to 6 months. Who will actually try to go to a competitor? Which obviously isn't good for us, because you can see that maybe you don't have as much data coming into the system anymore. You stop installing new applications. The administrators aren't logging in as often. The company is forgetting about this NetApp system that they have. And that's a warning flag for us, and we can send out a salesperson to at least ask what's going on. So if we already have the data, we can do a lot of smart things. And this is the way we built it. So in our booth, we talk about edge to core to cloud. This is our data pipeline, and it looks the same for pretty much any data pipeline. You have the edge, somewhere where you ingest data, where you collect data. In our case, it's our storage systems, but it could be an IoT device or a self-driving car. We replicate that data into the core data center where we do training, and then we have a connection to the cloud. So when we started doing this, we didn't want to buy a huge GPU server system just to do this test thing to see if we could proactively find out if hard drives are bad. Instead, we used GPU in the cloud to try our AI tactics and see if they were working, and they did. So we moved ahead, and we built a solution together with Nvidia, because Nvidia makes the best GPUs for AI and machine learning. So today we packaged the thing that we built for ourselves, we packaged it as a solution, and it's called ONTAP AI. And that was probably the last part of my sales pitch, so I'm not going to go any further with that. But it's a good system to get machine learning done quickly and take care of all of your data that you have in your data center. So with that, I want to hand over to Nvidia and Leif.
Oops, I lost or not.
I'm going to use this.
I was too quick to jump up, so I lost my transmitter here. Hello everybody, I'm Leif from Nvidia. So I'm working here in the Nordic market trying to help the customers that want to get started as NetApp did. So looking at the GPUs, how we can use the GPUs, what kind of software that you need, which is very dependent on what data you have today. So it all starts with the data. The data is really the source code. So when we started working, and I've been working for a long time in this industry, this is how it used to be looking. Lots and lots of servers in a room that were processing some kind of a code that a programmer had written. The difference now when we start looking into the GPUs and the technology there is that with the same footprint, or when it comes to performance, we don't need the same footprint when it comes to purchasing cost, electricity, and floor space. So it's just a matter of what parts of the workload, what type of analytics, and what kind of software solution that you have that can be run on GPUs. Because GPUs are so much faster than traditional CPUs. That's the whole basis of this research that we're doing. So when it comes to data analytics, we're really trying to then change the workflow that people is using today when they do this kind of work on the traditional data lakes, the Hadoop clusters, etc., etc. So we're going in there and trying to talk with the customers. Can we use GPUs for this, and what will it mean if we decide to use GPUs? And basically, it's going to be a lot less coffee drinking during the days. Because in the traditional world, you needed to wait for your runs. Your runs would normally take hours just to load the data, then a lot of more hours to crunch your data, and eventually we get a result day 2 or day 3. So basically what we're trying to do here is to speed up the process so that you can make several runs per day. There's always going to be one run which is sort of ready. And based on that, you can also, when you do more runs a day, you can get your results much more precise. Because then I can fine-tune my models, and I can do that in a much faster way. So that's the type of dialogue that we're trying to do. Doing this, of course, we need to look at the different stages of the actual workflow. So to start with, we're trying to parallelize the data preparation. So when reading the data set into the GPU machines, we need to change the way this is done today. So we are currently rewriting then the software stack so that the software stack becomes parallelized, and we can do this in a much faster way. Second stage is then to look at the actual crunching. So that crunching can be done on the GPUs. And why is it so much faster to do it on GPUs? Is basically because we have so much more compute power. Both in the terms of raw power, mathematical power, because there's 5,000 cores in every GPU, but also the fact that the memory bandwidth inside the GPU is 10 times faster than a CPU. And then a combined power of several GPUs, more than one, can be connected together on a very fast bus. A bus inside the machine, the Nvidia sort of bus where the GPUs talk directly to each other. So given that, we have an enormous, much faster bandwidth than you would have on a traditional CPU cluster. And then the final stage is, of course, then to try to do some kind of a graph or analytical result based on this is what we show over in the booth today. So basically you will have to have your result then presented in an attractive way. This you can do also with a parallel procedure where we also are writing the software for this. Nothing of this is sort of a fixed product. So we release new software versions of all these different steps every month. So we have a large team at Nvidia working on optimizing this kind of software for our customers. So we want more customers to give us input, what we should be looking at next, what is your challenge with your data set, come and discuss with us, and we can then change our software stack to more suit your needs. One of the customers that chose to do with us was a large retail chain in the US. So they can then look at the entire data set they have, given all of their sort of stock and all the stores, etc., in real time. This used to take days and days. It was not even possible to do before in real time. Now you can look at the data in real time. So that means that with these small changes in their sort of preparation and data wrangling, they can then save 1 to 4% on the total gross margin of their operations. And as you imagine, with such a large volume, you will save a lot of money with this solution. We not only work, of course, with this kind of data, we also work a lot with images. So when working with images, we have then computers that sits also not only in the data center, but also inside things like cars, robots, healthcare equipment, etc. So basically using the same technology, crunching and making very good neural network models, but we can then also deploy it in the field. We can deploy this algorithm in a car, in a hospital, in a robot that will sort of do some kind of function in an automated way. So looking at the automotive workflow, then some customers then, of course, much of this workflow is large scale. So it requires a lot of storage, petabytes and petabytes of storage, and then a lot of those GPUs to process the data. And this is also done in an iterative way. So it's very important that every night we can retrain our model, given the new input from both the test vehicles and the virtualized test environment. The combined power of that is very strong. It will, in the end, it will make us come closer to good self-driving cars with a very high personal safety functionality. So that's what we want to do with you guys. So we want to discuss what challenges do you have, what data set do you have, what is the volume, where are the bottlenecks, etc., etc. That's what we do then. In the end, of course, we want this to be beneficial to you guys, but that is nothing that you can sort of, design here on stage. That's something that we need to do in a dialogue. And that dialogue is led by our partner Konoa. Together with NetApp and Konoa, we are sort of, looking at how we can enable this then using basically the software solution that we have that then runs on this kind of architecture. So with that, I want to welcome our partner Konoa up on stage. Patrick, please.
Thank you, Leif. And sound is on.
Yeah.
I don't know if this one works. It does. So, hello everybody. As Leif said, and Fredrik before him, what we're talking about today is infrastructure for machine learning, deep learning, AI type solutions. My name is Patrick. I work from a local business partner, so we're based here in Stockholm in Sweden. We partner with NetApp, we partner with Nvidia, and basically what we do is design and implement infrastructure solutions to fit whatever need that you have in terms of machine learning and AI. And I want to start in this end because it might be obvious for most people in the room, and for some it might not be obvious, but there's 3 key things that you need to kind of bring into a discussion around anything that has to do with machine learning. One is data. Everyone's been touching data. Data is kind of the fuel that you're going to use for your calculations. To get the insight out of that data, to find patterns or to learn a system to recognize things or find different things. And you also need the algorithms. How many machine learning people do we have in the room? Any PhDs in machine learning, data scientists? Quite a lot of you. So you are the guys that are doing kind of the important stuff, the algorithms, the libraries, and kind of the brains behind this. But it's the combination of the brains, the amount of data, and the amount of compute power that you can use this on that kind of going to give you get you different results. So you might have the same library, the same kind of code, same amount of compute power, but different amounts of data is going to give you different results. And vice versa, you have the same data set, same algorithm, and the more compute power you're going to throw at it, the more and deeper you can go into your model, so you can get even better results, or you can do several projects in parallel, or your projects can go from 10 months to 1 month instead. So all of these three things are really important when looking at your kind of projects. And the most common question I get when talking to customer is, so this AI thing, we've been looking at it a little bit, or I've been thinking about it, but what's the use case for me, for my business? Where do I start? There's a few obvious ones that's already been touched, automotive and some in the industry. And I'm assuming here, being the audience that we have here today, there's quite a few of you that already are doing AI projects. But most companies in Sweden don't do it yet. So how do you start? And how do I find my use case? And this is what we want to talk to you about in our booth out here. And I put up a slide there, because the first thing I see that works on the customer that we work with is to get, you need to have an owner. You need to have an AI owner. Who owns this project? Because it doesn't fall into the normal kind of silos that you work in. It's not a database project. It's not a ERP project. It's not the traditional IT that most companies have. So it's a new division that's going to do things differently. So you need to have someone responsible. And then what we try to do is to get that person that is responsible to realize that he needs to talk both to business and to IT, because business, they know where the business is going. So what are the 10 strategic initiatives going forward the next 10 years, for example? And of course, the AI projects needs to support those strategic business decisions that you have. So you need to get them into the room, and you need to get IT in the room, because they know what data you have, in what format you have, where you have it, what you can share, what you cannot share, and what you can work with, and so on. And then you need to get them into a room and do a workshop. And the workshop could be anything. It could be anything from Nvidia's deep learning introduction workshops that we've done with customers, where you get people in and they get a touch and feel for what they can do. Or it could be more of a process discussion. If you're in a business like finance, for example, where you have tons of regulations. So what can we do, and how can we use data without exposing or breaching any rules and regulations that we have? So this is usually what we kind of recommend, and that we can help facilitate, and we can get people in from NetApp and Nvidia and so on, and share the experience that we have from local companies and from a global knowledge base from Nvidia, for example, and NetApp. So to round this up with 1 minute left, we have a booth. You can't miss it. You just walk out the door, and it's to the left. We're going to be here all day, and we're very happy to come over and talk to us. We're going to do I think it's not on here, but we're going to have a half-day workshop on 12th of April. That's going to go deeper into the subject that we talked about today. So come over to the booth, get the personal invite, see if you can join that one. We're doing some competitions, some prizes. You can get a lot of candy. Anyone fed up on candy yet? And with that, I'm just going to want to wrap it up and say thank you for your time, and please join us in the booth.
Thank you.